In this lesson, we're going to talk about multiple derivatives and power series. Please click the like button to get more content and essential tutorials. When we take multiple derivatives, we just repeat taking the derivative over and over again. In this case, we use the notation f raised to the n. N is the number of times that we take the derivative dny dx to the n. If we evaluate the nth derivative at some point at x equals 0, in this case, we just substitute 0 in for x, and we also use this evaluate sign, the straight bar with the subscript x equals 0. If we do it at x equal a, we substitute it in x sub a, and again, we use the straight bar with x equal x sub a. We use the standard prime notation. F prime is the first derivative of y with respect to x. F double prime is the second derivative of y with respect to x. Multiple derivatives of the y equal to cosine x is a brain teaser. Zeroth derivative is just y cosine x. First derivative, minus sine of x. Derivative of cosine x is a minus sine x. Second derivative of a minus sine of x is a minus cosine of x. Third derivative of a minus cosine x is a plus sine x. Fourth derivative of sine of x is equal to cosine of x. Now it repeats. Derivative of a polynomial, what is that? First derivative, we simply reduce the power of x, take the power of x, multiply it times the coefficient. So a0 derivative of that is 0. Derivative of a1x is a1. Derivative of a2x to the 2 power is 2a2x, and so forth. What about the second derivative? Well, we take the derivative of the first derivative and repeat that. 2ax, the x goes away. Now we get 3 times 2, a3 to the x, and so forth. What about the third derivative? In this case, we reduce the power again. The a2 term goes away, and we get 3 times 2 times 1, which is 3 factorial times a3. And then this term, the a4 term, we get 4 times 3 times 2 times 1, which is 4 factorial, and so forth. In this case, we're going to build on the derivative of the polynomial, the multiple derivatives. The nth derivative is defined here. The zeroth derivative is just y. So what happens if we evaluate at x equals 0, the zeroth derivative? Well, all the higher order terms go away. It leaves us a 0. Interesting. Now let's take the first derivative of the polynomial and evaluate it again at x equals 0. It gives us a 1. Let's continue. First derivative is repeated here. The second derivative is this. Evaluating at x equals 0 gives us 2a2. Third derivative, evaluating that at x equals 0, gives us 3 times 2 times a3, and so forth. When we put it all together, we get what's called the Taylor series expansion. In this slide, we're going to look at the Taylor series expansion of the cosine of x. F0 is just cosine of x. Evaluating that at x equals 0 gives you 1. What about this? The first derivative of the cosine of x? Well, it's the minus sine of x. Evaluating that at x equals 0 gives you 0. How about this one? The second derivative evaluated at x equals 0. Second derivative of cosine of x is a minus cosine of x. Equals a minus 1 at x equals 0. The third derivative, taking the derivative of minus cosine of x, gives you sine of x. Evaluating that at x equals 0 is 0. The fourth derivative of sine of x is cosine of x, which gives you 1 at x equals 0. So putting that all together, and we see this series repeats, 1, 0, minus 1, 0, 1. We get y is equal to 1 minus 1/2 x squared, which is the approximation we talked about in the past, plus higher order terms, 1 over 4 factorial, x to the 4th. So it's only even terms. Please click the like button to get more content and essential tutorials. Subscribe as well for future updates. Thank you.